Okay, we're going to do the remaining rational equations that you will probably get something similar to this on your quiz. They're right here, and we're doing the same thing, finding the wholes, etc. of these. So for number one, the thing you need to remember is this equation here. You'll be using it again in sections 3.6 and 3.7. So make sure you get this down. And then we're going to do this last one, number two. And again, I will graph them. So the first one is here. And right away, when I'm looking at this, I notice that my degree in the numerator is 1 higher than the degree in the denominator. So that means I'm going to have an oblique asymptote. Don't know what it is yet. I am not going to have a horizontal because you can't have both. So no horizontal. I don't have to deal with the range since I have an oblique. So I'm going to write that as non-applicable, and I've answered a lot of questions already. Well, the first thing we want to do is factor this. So remember that from the first slide that a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. In our case, our a is x, and our b is 2, because 2 cubed is 8. So I get x minus 2 times x squared plus 2x plus 4. Alright, so let's go back up here, and we're going to write it out. We get x minus 2 times x squared plus 2x plus 4. And I'm going to factor my denominator. I get x minus 2 times x minus 3. So right away I know for my domain, I have x cannot equal, it's x such that x cannot equal 2 and it cannot equal 3. That means I'll have a vertical asymptote at x equals 2 and 3 if I didn't have a hole. But I have a hole here. So I know the one with the 2 here is not a vertical asymptote. That's part of the hole, but my vertical asymptote is y equals 3. And to find my hole, when the x is 2, what's y? I plug that in, and I'm going to get, I'll do that in this area here. And I'm just working with my depressed equation here, so I'm going to get 2 squared plus 2 times 2 plus 4 over 2 minus 3, which gives me negative 12 over positive 12 over negative 1, which gives me negative 12. So I do have a hole here, vertical asymptote. I don't have a horizontal asymptote, but an oblique, and we're going to find that out next. So we're going to take the depressed equation and use long division. So we have x minus 3 goes into x squared plus 2x plus 4. And divide this out, we're going to get x here. X times x is x squared. X times negative 3 is negative 3x. Subtract both pieces, and we're going to get 5x plus 4 when you bring down the 4. And then this is going to be plus 4 here. No, plus 5 actually. And you multiply and you get 5x minus 15, and basically you can stop from here because you have your linear equation. You're done. So my oblique asymptote is y equals x plus 5. Now I have to worry about the roots and the y-intercept. So when I look at this, I have x squared plus 2x plus 4 over x minus 3. And if I look, set this to 0 to find my y-intercept, what I notice is I can't factor this. So there's no real roots. That means we won't have any x-intercepts. So you can just put, for or for roots, just put none. Now for the y-intercept, I'm going to let x be 0 and plug that in. I'm going to get negative 4/3. And I think we got everything. I'll do a little quick graph here, what this looks like. I do have a vertical asymptote at x equals 3. So we got a vertical asymptote at x equals 3. I have an oblique asymptote at y equals x plus 5. So I'm going to go 1, 2, 3, 4, 5. And that's going to go here. The slope is 1. So that's just a little oblique asymptote. Alright. Y-intercept at negative 4/3, which is a little bigger here. And so this is what this looks like. It's like this. It's close to that, and it does that. And there she is. There's no x-intercepts here, if you notice. Okay, there's no real roots. Let me draw this a little better. There's your slant asymptote, as you would want to call it. Alright, the next problem, or the last problem, is f of x equals x squared plus 4x plus 8 over 4x. Alright, so for the domain, it's all reals, but x cannot be 0. I have an oblique asymptote because the degree in the numerator is 1 higher than the denominator. So I have an oblique. That means I don't have a horizontal. I can write NA on that. Also, there's no holes. Thank goodness. Non-applicable. I do have a vertical asymptote at x equals 0 from my domain part. Remember, those two go together. Y-intercept, I have none. Because you can't divide by 0. So I can't even let x be 0. So there's none. My roots, I have none. Because basically I cannot factor this. If you use the quadratic formula on this, you'll get imaginary solutions. The only thing I can do here at this point is find my oblique asymptote. And the one thing that's different about this is that we're dividing by 4x. And when you do that, what times 4x gives you x squared? You're going to have to say 1/4 x. So 1/4 x times 4x is going to be x squared. And that zeroes out. Bring down the 4x. What times 4x gives you 4x, and that's going to be plus 1. So we do have an oblique asymptote at y equals 1/4 x plus 1. So that's a little different. And some of your versions might have this on your daily work or on your quiz. But everything else was pretty easy. And I'll do a quick sketch. Alright, so we did have vertical asymptote at x equals 0. So right in this area. I'll just draw that. That's a vertical asymptote. There's no holes. The oblique asymptote is at 1/4 x plus 1. So there's, let me do that in a different color. So there's your y-intercept. You're going up 1/4, down 1/4. So let me try to draw this. It's hard to draw on the iPad. Anyway, here you go. And there was no x-intercepts nor y-intercepts. So it's not going to cross, and it looks, this is what the graph would look like. I just want to show you what the graphs look like, even though you don't have to graph, because I think it gives you an idea of how this is real. And that is it. Good luck on your quiz.